So in this video, we will be discussing the way to assign the values of unpacked array to packed arrays and packed arrays with unpacked arrays. So let's begin. So in the first example, I will be showing you how to assign the value of packed array to the elements of unpacked array. So let me write an module and I will declare an unpacked array. I will name it UARR. So this particular unpacked array has three elements, and each three elements has these two dimensions of packed array, and those dimensions are 4 times 8. So basically it's a bit vector of 32 if you multiply 4 times 8. So this is an unpacked array of elements that are packed. So what I will do, I will declare some packed arrays and I will assign those packed array to the elements of this unpacked array. So let me write some packed array, and for this example I will write a 32-bit packed array, and let's give a value in hex. Okay, fine. Now what can I do? I cannot directly assign the value to unpacked array, else it will show an error. So what happens if I directly assign this particular packed array to this unpacked array? Let's find out. So I will write my initial begin block, and inside it we'll assign the value, and let's find out what will happen. We got an error. So as you can see right here on the console, that it clearly mentions that cannot assign a packed type, which is this, to an unpacked type, which is that. So what can we do? So there are lots of ways. So for this example, I will be assigning the value to each element of this unpacked array. And remember, this unpacked array has three elements, and each three of them are packed. And you can assign the packed array to packed array. So how can we address the individual elements of this unpacked array? So as I have already discussed in my previous video, you can do that by referring to each dimension. And the dimension begins with the right side, which is the unpacked side. So this is the first dimension. So there are three elements, and then you begin from the left side, left to right. So there are three elements, and inside three elements there are four packed elements, and inside each four packed elements there are eight packed elements. So dimension begins from here, then it begins from here. So since this particular value is of 32 bits, and if you combine our second and third dimension, it is a contiguous bits of length 32. So we can directly assign to any element of this unpacked array. So let's assign the value to the 0th element, and that 0th element is 4 times 8 bits. And what's 4 times 8? It's 32. So it should assign perfectly. First, let's check for any compilation error. So as you can see, the compilation was successful without any error. And the reason is that because we are referencing the 0th element of this unpacked array. And the 0th element of this unpacked array is packed. And here we are assigning a packed array to an unpacked array. So that's why we are not prompted with any error. So let's go ahead and display the value. Okay, I will rather use for each or nah. First, let's check for any possible compilation error. Okay, there are some errors. Let's find out. Oh, it's UARR. Okay, let's run the code for one more time. Okay, it's fine. So let's go ahead and simulate the code. As you can see right here, we did get the assigned value. And since we assigned the value to only the 0th element of this unpacked array, the remainder of the elements are getting the default value. And the default value for the bit data type is 0. So we can also directly assign values to the elements of this unpacked array, and we can do just this. And let's reference to the first element, and inside that first element we can reference further to the let's pick the third element, and each elements in the second dimension are of 8 bits. So let's give some 8-bit value. Uh, okay, so I will move this for each underneath this. First, let's check for any compilation error. Okay, the code is fine. Now let's simulate the code. As you can see right here that the value is assigned to the second dimension here, and allow me to use fold each in a better way. And to do that, I will just paste it right here, and I will reference every element till second dimension. Okay. Now let's run the code for one more time. So this particular value is stored to the first element, and in the second dimension it's the third element. So let's find out. Okay, I did make some mistake. Hold on. Let me first compile it. Okay, the compilation was successful. What's the problem? Okay, let's run it again. Oh, all right. Oh, I got it. Should be J. No, it should work fine. As you can see right here that the elements are getting printed correctly, and here you can see we have that value. and this is the value which we assigned previously. So just to make it more clear, what I will do, I will just add a delay and also I will print the value in hex, and let's simulate the code for one more time. Yeah, you can see the value 4a. 4a. So we can also reference to the third dimension, and as I've already discussed, that the reference begins from the dimension declared on the right hand side in left to right fashion. Then it follows the dimension which are declared in the left hand side in the similar fashion, that is from left to right. So this time I will reference to uh, the second element or the final element, and inside the second element let's refer to the first element, and inside that let's reference to uh, fourth element. And here if we are referencing to the fourth element, then in this particular dimension every element is of 1 bit. It is obvious. So let's assign a 1 bit value. So let's run the code for one more time, and this time in for each I will make one more modification. First I will check for any possible compilation error. Okay, it's fine. So let's simulate the code. Okay, we have to look for the this particular dimension. Uh, oh, here you can see right here that the value 1 has been assigned. So yeah, it works perfectly. Other than that, we can also assign any element of this unpacked array to any packed array. So for example, let me write another packed array of, let's say, 32 bits, but the bits are divided into multiple dimensions. The first dimension is of 8 bits and the second dimension it's of 4 bits. Num and in the next time slot or in the same time slot, let's assign the 0th element to num. And as you can remember, we have already assigned this particular value from this packed array to the 0th element of this unpacked array. Then we will display the value. Let's check for any compilation error. And let's run the code. Okay, as you can see, it might seem confusing, but the percentage %p prints every element of this array. And here you can see we are getting the exact value. So these are some of the ways in which we can assign the values of packed array to the elements of unpacked array. But there is a more feasible way of doing the same. So I will introduce you the usage of streaming operators. So streaming operator is very powerful and very useful. It can pack an unpacked array and can assign it to any packed arrays. And also it can unpack and pack array and assign it to any unpacked array. So for this example, let me write the module name for one more time. So let's declare an int, and this is by default packed. So first I will declare an unpacked array, and let's name it J, and it will have 4 elements, and each element will be of 8 bits. Okay, so if you will calculate, it has 4 elements, and since each element is of 8 bits, so there are like 32 bits in total, but in unpacked array, it doesn't work like that. So just to showcase, it will be like that, that the first element will have 8 bits like this. Let's give some random value. And then since it is unpacked, then the remainder of the bits will be 0 or nothing till it's get 32. And same goes for another element. So if we assign the value of this unpacked array to this value h, which is packed, what it will do, it will just pack everything, every element into contiguous bits, and then it will assign it to this packed element or packed value. So let's do this. I will begin with my initial begin. And this is how we use streaming operator. So to do that, you just have to use curly bracket and in this. So this arrow signifies that we are using an streaming operator and the direction matters a lot. So right now we are pointing the streaming operator from left to right. So it will pack all the elements of this unpacked array from left to right fashion. So first, let me give some value to this unpacked array. So the first element is A, and the second element, let's give it B. For the third element, let's give C, and for the fourth and final element, let's give D. So what it will do, it will pack every element into the set of contiguous bit and it will assign it to H. So since I am pointing from right to left, it will do from rightmost element to the leftmost element. So let's find out. After doing this, I will display the value of H. Now let's go ahead and check for any compilation error. Okay, let's simulate the code. As you can see right here that it takes all the elements of the unpacked array and it packs it and it packs it into a value which has contiguous bits and then it assigns the value to this packed element. It is wonderful and it is very powerful. So using the streaming operator, you can transfer the values between packed and unpacked array. So what happens if I change the direction of this streaming operator? Let's find out. So I will give a delay and then I will change the direction of the streaming operator. Let's run the code for one more time. So as you can see right here, for this time, it packs the element from the right side to the left side. So what is happening right here is that the stringing operator packs the element and it will look something like this. 0A and then B, C, D. So it collects the value and packs it, and then it assigns it to the variable h. But in this particular case, since the stringing operator is pointing from right to left, it will just reverse this collected value and assign it to h. And that reverse value is this. So what if you want the elements to be packed on a byte basis? Like, for example, if you want something like this, that the first element will be packed like this, and the second will be C, and the third will be B, and the fourth will be A. So here I want to reverse the value on the byte basis. Like, first it will put this to the leftmost side, then this, then this, then this. We can do that by making a little modification right here. So I just have to add byte. Now this will pack the element in the reverse direction on a byte basis. So let's run the code for one more time. So as you can observe right here on the console, that the elements of the unpacked array were reversed on the byte basis, and then they were assigned to the packed element or packed value or variable h. So this is how powerful the streaming operator is. Now I will assign the elements of packed arrays, and I will unpack their values together and assign it to this unpacked array. For this, first I will declare for unpacked array, I mean the packed array. Each unpacked array will be of 8 bits. Let's name them Q, R, S, T. And here, after a delay of 1, let's give them some value. So let's give it Okay. Now we can assign the values of this packed arrays to the each of the elements of this unpacked array using the streaming operator. First, let's check for any compilation error. Okay, the compilation was successful. So I also have to print the elements of this unpacked array. So to do that, I will use for each, and I will only refer to the first dimension. So let's go ahead and run the code. As you can see right here that the each of the elements of this unpacked array J is assigned with the elements of this packed array. So yeah, this is the streaming operator. And using a streaming operator, you can assign the values of packed array and unpacked array with each other. So that's all. I hope you find this tutorial useful. Thank you so much.